Alright, this lesson is going to be a foundation for us moving forward through this course. We're going to be talking about some common characteristics that we need to discuss about particular graph shapes. We're just going to set the foundation here by talking about these characteristics and apply them to a couple of random examples that we're going to use in this lesson. But we are going to be revisiting all of these each time we move to a new unit. So, like for instance, next unit, unit 1 is going to be on absolute value, so we're going to see how all of these characteristics would apply to an absolute value graph. Then we're going to do the same thing for quadratic, quartic, and cubic. So we're going to keep working with these characteristics over and over again. So if they don't quite sink in for this unit, rest assured you'll see them again and have even more time to practice as we move forward throughout the year. So it might seem a little overwhelming at first because there are a lot of things that we're going to be working with. Many of them you guys should know already though. So we've already talked about domain and range. Those are things that we're going to revisit each time we get to a new graph. We're going to look at something called increase-decrease, which is new, but you guys should be familiar with x-intercept and y-intercept. So really the only thing on this page that's new is this little center section. Then we're going to talk about end behavior and then relative maximum and minimum. So all of those things are what we're going to be talking about. So you'll see this kind of setup every unit. We see a new type of graph. We're going to have a particular type of function, and we're going to go through all of these things for that particular function, and we're going to do that every unit throughout the year. So let's go ahead and just reset our foundation. Let's revisit domain. So our domain is a set of input values that produce an output value. So in other words, it's our set of all possible x values. Just like we talked about before. We're going to practice both our set builder and our interval notation for this. We've seen both, and I expect you guys to know both. So make sure you guys are keeping all that information fresh in your mind. So if we look at this graph over here, which is what we're using as our reference, you'll notice that the very first x value of our graph, the furthest left we can go, is at -4. But it never stops as it goes to the right because of this arrow right here. It's going to go down and to the right forever. So our graph is going to be from -4 to infinity. That's how we would express it in interval notation. In set builder notation, we have to use an inequality. So we're going to say x such that x is greater than or equal to -4. It's equal to because this is a closed dot right there, and it's greater than because we're going to the right of -4. All of the x values would be either -4 or a number higher than that. And for interval notation, again, I said that out loud a second ago. So our domain is from -4 to positive infinity. So that's how we would express our interval notation. Use a square bracket because we're equal to -4. We use a parentheses around infinity because you would never actually stop there. So again, that shouldn't be brand new because we talked about that already. Alright, now I'm going to switch to range. So the range is the set of all possible y values. So now we're going to be looking along the y-axis, which is up and down versus left and right. So if you look at this section right here, that's the highest y value that our graph reaches at 5. And the lowest y value, again here, it would actually be -infinity is the lowest we go because we go down forever. So because our graph is going down forever, we would use -infinity at some point in our range. So again, in set builder notation, we're going to use an inequality. We always use inequalities when we're working with set builder notation. So because our graph is starting at 5 and then going below 5, we're going to be using the less than or equal to inequality. And again, it's equal to because we have an actual point here at 5, so 5 is included in the set, and every value below that is included, so that's less than. If it were the other way around, so the graph was like up here above the 5, then it would be greater than. So just think, is it above the number or below the number, and that helps you figure out whether it's less than or greater than. And then for interval notation, remember you always write interval notation for a range going from bottom up. So because the lowest y value is -infinity, I'm going to start there. And the highest y value is 5, and it is included, so I use a square bracket. So interval notations from left to right and then bottom up when you're writing. Alright, so things you guys should be familiar with are. Now we're going to talk about increase, decrease. Okay, so increase, decrease is a good idea to use color coding when you're working with this. So basically, the interval of increase is where your graph, if you were tracing the graph, it's where your graph will be going up as x increases. So basically, if you were tracing the graph, going from left to right, if you were tracing the graph, any part that you're going up, like I am right now, would be increasing, and any part that you're going down, that's a little confusing, I'm going to not keep that there. Any part that you're going down from left to right, or as x increases, that's called decreasing. So if you're going up, it's increasing. If you're going down, it's decreasing. It's pretty straightforward. But what you guys need to notice is that I'm talking about this in terms of x. So I said as x increases and as x increases for each of these, right? So it's important to know that when you guys are writing the intervals of increase, decrease, it's always in terms of x. Another way that you can think of this, I should have written here, but you guys can write it down for yourself in the margin if you'd like. Another way of thinking about increase, decrease is what is the section of the x-axis that is within the portion of the graph that's going up or down. So that will become more clear when I use my color coding. So we're going to use color coding to help us. So I'm going to trace the part that's going down in red. So again, if you're reading the graph from left to right, if you're tracing it with your pencil going from left to right, I'd be going down, and then up, and then down again. Okay, so color coded this way, use one color for the parts that are going down and a different color for the parts that are going up. So the part that I'm going up is this green section. Okay, now when I write the interval of increase, decrease, or increase for this part we're about to do right now, I'm going to draw a little dashed line kind of up to the x-axis right here from both parts, where it starts and where it stops. Okay, so it started increasing right here, so I kind of come up and I put a point right there, and it stopped increasing here, so I put a little dot right here. So this little section right here that I just highlighted on the x-axis, that's the interval that I want. Because increase, decrease is asking where on the x-axis is the graph increasing. So from this little arrow or dot right there to this little arrow or dot, that's the part where it's increasing. So I'm going to write that as an interval. So if you look, it's approximately -3 over here on the left and approximately 1 on the right. So my interval of increase is going to be from -3 the x values. So from x equals -3 all the way x equals 1, that's the portion of the graph or the x-axis where the graph is increasing. Now we're going to do the same thing for decreasing. So let's start on the far left. We always read from left to right. So on the far left, this right here is where my graph starts decreasing, and I kind of go along, and then it stops decreasing right here. So this little section of the x-axis, that is the section where it is decreasing. So that's from -4 to -3. It's a really small section of the graph. This little piece right here, where it's decreasing. Now notice there is a second part where it's decreasing, so I'm going to jump over this green section that I already took care of, and I'm going to go to where it starts decreasing again, which is right here. Okay? And then it keeps decreasing, keeps going down, keeps going down, keeps going down, keeps going down. So all this part right here, it's going down, 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 down. It'll keep doing that forever. So I'll be able to keep tracing the x-axis forever to infinity. Okay. So this section over here, this little piece of decreasing is going to start at 1, and then it's going to go all the way to infinity. Okay. Now notice that this little green section breaks the two red parts in half. So remember when you guys are writing two intervals and there's a gap or a jump inside, you need to make sure you write a little u. So if you have more than one section of the graph that's either increasing or decreasing, put a little u in between the two intervals, and you'll be good to go. Another way that you can help yourself here, not only with the color coding, like tracing the graph with 2 different colors and then shading in the x-axis with those colors too, you could also write the numbers. Some students like to see the numbers actually written out. You will not be using any other numbers except for where these intervals start and stop. So you should notice also, when you guys are looking at your intervals, when I stopped at -3, my other interval picked up from -3 and then went to 1. When I stopped at 1, my next interval started there. So they should have the same numbers. An interval is going to end and then a different one's going to pick up from the same number. So you have everything kind of covered with all of those intervals kind of mixed together. So you should see the same numbers show up when you're working with increase decrease. This is possibly one of the more complicated concepts that we're going to be working with, because again, when you're thinking increase decrease, you want to think up versus down. But what I'm actually asking for are x values, which is left versus right. So you still need to think up versus down to know what part is actually increasing or decreasing. But when you guys are writing the interval, I'm only interested on where on the x-axis that increase or decrease is happening. Okay, so it's a little bit of a counterintuitive idea there. It takes some getting used to. But again, use your color coding, write the numbers down if you need to. That can be helpful in that process. And then just a reminder, to emphasize this, you can write it really big underneath this last statement. When you're trying to find intervals of increase, decrease, or something called a constant interval where your graph is flat instead of going up or down, we're always going to be focusing on the x values. Alright, I'm going to erase this mess. So we're going to start fresh for the next little bit. Okay, the next 2 things we're going to talk about are the x and y intercepts. So this is something you should be familiar with. So the x-intercept is the point where the function crosses the x-axis. That's the definition. Now, we talk about x-intercept a lot in this course. We're going to see 3 other terms that are interchangeable. So you could also see a root, or be asked for a root, a solution, or a 0. All of these terms are interchangeable. So if I ask for an x-intercept, that's the same thing as asking for a root or a 0 or a solution. If I ask for a solution, that's another way of asking for an x-intercept, a root or a 0. So any of these 4 words are interchangeable and they're referring to the same thing. The way that you write them is a little bit different. Like the x-intercept is always written as a point with coordinates, but the root, solution, and 0 are always written with x equals, and then you write the number. So the way you write it can be a little bit different, but they're all related to each other. So for an x-intercept, you'll always write it as a point x, 0. But for a 0 root or solution, you would write it as x equals. Okay, so we're going to list the x-intercepts of the graph up here. So again, you want to look here, here, and here. We have 3 spots where it hits the x-axis. So we have -4. We have -4, 0. We have -1, 0. And 5, 0. So again, this should be familiar. Not too crazy. That's going to be your x-intercept. Now we're going to talk about y-intercept. That's the point again, where the graph crosses the y-axis. Should always be in the form 0, y. So let's take a look at the graph this time. The the y-intercept is right here. Use a different color. Okay, so that's our y-intercept, where it crosses the y-axis. Set that 0, 3 as a point. Something important to notice is that for the x-intercepts, I had 3. You can actually have as many x-intercepts as you want, depending on how you graph it. So you can have 1, 2, 3, 4, you could have none, that kind of situation. For the x-intercept, there's really no limit to how many you can have. But for the y-intercept, you should only have 1. If it's a function that passes the vertical line test, you should only have 1 y-intercept. If it's not a function and it's kind of like looping around everywhere like this, obviously you can have more than 1 y-intercept. See, this kind of example right here. But when it's a function, you'll only have 1 y-intercept. keep that in mind when you guys are going through examples. All right, the next thing we're going to talk about is end behavior. So end behavior describes a function as x approaches positive infinity on the right and negative infinity on the left. So, in other words, it's telling you what's happening with the y values, or the ends of the graph. So I'm going to circle these two arrows. When you guys are working with end behavior, it's really looking at the arrow behavior, because the arrows at the end of your graph are indicating whether you're going up or whether you're going down. That's really all that's interested in. Are you going up or are you going down? It's a very simple concept on its face. The only thing that can get a little bit complicated is understanding how to write this in notation. So I'm never going to ask you guys officially to just say whether it's going up or down in words. That's a good place to start. But I'm always going to have you guys write your answer in notation, which is illustrated right here next to these red stars. So, like this little section was saying, on the right, when we're trying to say that a graph is going to the right, we say that x is approaching positive infinity, which is what I have represented right here. So the x is there, the approaches is represented by the arrow, and the positive infinity is right there. So this is another way of saying go to the right. And then the f of x obviously stands for the function, the y's. So on the right side of the graph, which is right here, what direction is my arrow going? Down, right? It's going down. Now the way that we represent down, like we've talked about with interval notation for domain and range, is by using negative infinity. Okay, so if I ask for the end behavior, I expect you to write the x is approaching positive infinity for right, and then f of x is approaching negative infinity for down. On the right side of the graph, it's going down. Okay? So this is kind of the easy way of saying it, but then you have to make sure you know how to write the notation. And then alternatively, if I say that x is approaching negative infinity, that means that you're going to the left. If you're going towards negative infinity on the number line, it's going towards the left. So as x is going towards negative infinity on the left, that's over here, you can clearly see that your arrow is going up. And like you would expect on a number line or with domain or range, up, or range specifically, up would be positive. So for the full notation, you would write x is approaching, or x arrow negative infinity, comma, f of x arrow positive infinity. That's how you say on the left, the graph is going up. Okay, so again, if you think about it in words, write it down in words, it'll make a lot of sense. Just say on the right side it's going down, on the left side it's going up. It's a great place to start. But then you guys do need to train yourself how to translate those words into the official algebraic symbols or notation. That's what's tricky about that. Okay. Now we have our relative or local. Relative and local are two words meaning the same thing, so you could use either of those interchangeably. So when we're looking for a maximum or a minimum, you're going to be looking at your graph. Another way of looking for a maximum is to look for hilltops. So you're looking at how your graph is curved. Kind of you're looking at the bottom of curves or the top of the curves. So a maximum would be an upper point. So if you see a hilltop like this, the tops of the hills, those would be considered relative maximum. We're also going to talk about something called absolute maximum, which is when you have a highest point for the entire graph. When we're talking about relative or local, we're talking about just high points in general. Okay? We'll talk about absolute stuff a little bit later on. So it's the point with the highest y value in one section of the graph. So again, you're looking at pieces of the graph to find all the different high points that you might see. So look for those hilltops. Each one of those hilltops represents a relative maximum. So one of those hilltops is at -1, 9. And then we have another hilltop at 38. If I ask for a local or relative maximum, that's what you would write down. We also have relative or local minimums. So if you're looking for a minimum,
Students, is it time for after school lessons? Please get a pass from the teacher you are with. You will not be allowed on the buses without a pass. And then go ahead and head to door 12.
When you guys are looking for a relative minimum, instead of hilltops, you're going to be looking for a ditch. So it's going to be a lowest point, the lowest Y value in one or more sections of the graph. So you're just looking for all those low points. So this graph only has one ditch. So that's going to be one minimum. I'm kidding, there's another one right here. Sorry, there are two little dips in the graph already. So those are going to be our two relative minima. That's the plural minimum. So one of those is at negative 4, 1. That's the one on the left, and the one on the right is at 1, negative 3. I counted right. Okay, so those are pretty easy to spot as well. Just look for hilltops and ditches. So you've got your minimum and maximum for the relative. Great. We're going to go ahead and bring back the concept of increase-decrease because, again, I think that's probably the most complicated. So we're going to practice it again on this new graph. So again, you guys want to get your two different colors out. I can't remember which ones I used for which. I'm going to use blue for decrease, so it's going down, and then green for going up, and down again, and up again. And down. Okay? And then remember, what you want to do is we're not talking about Y values for increase, decrease. We're talking about where on the x-axis is the increase or decrease happening. You want to drop down. Okay? So this little section right here, that's the part of the x-axis that contains that green section where it's increasing. So I'm going to hold that thought. I'm going to come over to the next green section right here and fill that out. Okay. So then this is also a section of the x-axis that contains a green increasing portion of the graph. So those two little sections that I highlighted here, these are the intervals that I'm going to write down for my intervals of increase, decrease. So over here, it's at, let's see, this is negative 4, this is negative 1, positive 1, and then it's getting a little blurry on the screen, but I'm pretty sure that's 3. Yes, that's 3. Okay, so I'm going to use these numbers. I go from negative 4 to negative 1, and I go from 1 to 3. Those are my intervals of increase. Negative 4 to, I already forgot, negative 4 to negative 1, and 1 to 3. Remember, because there's a gap, there's an empty space where I jump over, you have to use the union symbol to represent that. Alright, so I just took care of the increasing part. Now for the decreasing. Okay? So because this arrow is going up and to the left forever, my x-intercept section is going to start at negative infinity and then come up to this point right here. Right? So from negative infinity in this way, from negative infinity to negative 4, that's the part of my graph on the left that's decreasing. That's going to be one part. Negative infinity to negative 4 is decreasing. And then negative 4 to 1 is increasing, like we have right here. Okay? And then from this point to this point, this little section right here, I'm tracing right now, that section is in between negative 1 and positive 1. That's the interval of the x values that contains that decrease. So my next little section would be negative 1 to positive 1. And I still have more. So then I'm also decreasing from here to here, which would be infinity. So this little section right here, starting from 3 and then going all the way to the right forever to infinity, would be my next little section. So again, look at how we color-coded this. You should see that every single piece of the x-axis has been filled in with a particular color. They alternate. First it's blue going down, then it's green going up and down and up and down. You can see the entire x-axis has been colored in. You just need to figure out from what number to what number contains going up as opposed to down. So that's why it's important that you guys color code. First of all, trace your graph with a particular color, and also make sure that you're drawing these vertical lines to show what points are actually representing change, whether you start going up or start going down. You need to represent those little points on the x-axis. So hopefully the color coding will help you guys, especially if you actually write the numbers out. You can see what you're working with. You shouldn't use any other numbers except for the ones at those points. Well, plus the infinity on the right side and the negative infinity on the far left side. Those will always be constant on the far left and on the far right. You would have negative infinity and positive infinity. And then I also very briefly am going to bring in the idea of a constant interval. That's if your graph were flat, like a plateau, neither going up or down, that would be a constant interval. This picture that we have in front of us does not have one. An illustration of that would look like this. You got something like this. This little piece right here is what we would call a constant, where it's horizontal, flat. You will not see that very often, but if it were in your graph, you would just say again, like if this were the x-axis right here, you would just say, okay, what's this number, and then your interval would be in between those two, the same way that you would for an increase or decrease. Right, so we're going to pull all this together with 2 examples. We're going to start from the very top and do all of this. We're going to do domain and range. We're going to talk about minimum and maximums, increase, decrease, or constant if we have one. Our intercepts are zeros, which again is linking back to the x-intercept. Like I talked about, the zero, root, solution, x-intercept are all equivalent. And then lastly, the behavior. You're going to see these charts repeated over and over and over again. As we go throughout the year, we're going to apply this information to different types of graphs. So let's start with this first one. So for the domain, again, you want to think, what's the furthest left? What's the furthest right? Where do I start? Where do I stop? That kind of thing. So if you notice that this arrow right here is pointing forever to the left, that means that my left bound, where it starts, quote unquote, is at negative infinity. And then as we continue reading our graph from left to right, that's how I always read a graph, right? So I'm going along, right? I stop here, this is an open circle, but I pick up right here with a closed circle. So this little gap doesn't really matter. I just kind of go and then I pick up and I keep going, and I keep going, and keep going forever. So our domain for this line is going to be negative infinity to positive infinity. The little gap right here doesn't matter because the open circle is taken care of with the closed circle. It just picks up and keeps going. So it goes from negative infinity to positive infinity without stopping. Okay. Then the range, and I'm only using interval notation here, but make sure you guys are okay with set builder still. That's for going forward. The range is going to be from bottom up. So the lowest y value, if I draw this line right here, everything above that line is part of my graph and there's nothing underneath it. So this value right here is the lowest y value I have, which is at -3. And then everything is going above that to infinity. So I would start at -3 and then go up towards infinity forever. So that's what my range looks like. It's -3 up to infinity. Put this arrow at the top. Great, now we're looking for a local minimum or maximum, and again, what you're wanting to do is look for hilltops and ditches. So we don't have a relative maximum because there are no hilltops. We also wouldn't have an absolute maximum because it goes forever to infinity. So we don't have a true highest number because you can't stop at infinity. But we do have a lowest value right here. This is both a relative minimum and an absolute minimum because it's the lowest point on the entire graph, as well as in a kind of smaller section if you wanted to look at it piece by piece. So this would serve the purpose of both a relative and an absolute. But in any case, we're going to write that as our minimum. So that ditch right there that represents our minimum is at the point 0, -3. Don't have a maximum. Alright, now we're going to do intervals of increase, decrease. I'm going to go ahead and highlight that. So I'm going to have increasing in red and decreasing in green. This little flat section off to the left is what we're going to call a constant interval, which we talked about just a second ago. We're going to wait on that for a second. Alright, so the two values that I want to focus on are these two right here. So this section of my graph is green. that represents my decreasing. That's the little sliver of the x-axis that contains my dip, my decrease in the graph. So for my decreasing, I'll go ahead and do that first, just because we're reading left to right. So I decrease from the value -1 to 0. Between x equals -1 and x equals 0, this little section of my x-axis is where my graph is falling. My graph is rising, starting at 0 and then continuing forever and ever and ever and ever, because it's going to go to the right and up forever. So my increase is going to start at 0 and continue increasing to infinity on the x-axis. So again, you can see the highlights from -1 to 0, and then from 0 to infinity with the alternating. The constant interval, that's going to be this little piece right here. Okay. Constant interval, you're going to go ahead and write that the same way you would for interval notation. So on the x-axis, it would be this blue part. So from -infinity until -1, that's the part of the x-axis that contains this flat horizontal piece. So from -infinity to 0 contains this little piece right here, which is flat. So you would just write that as same kind of system you would use for increase decrease. You're just looking for something different. All right. Next up, I'm going to go ahead and erase all of this just so our graph can be seen and all the numbers. All right. So our colors are. Our x-intercept is where our graph is going to cross the x-axis. That's not a whole number, so I'm going to call that approximately 1.8. So 1.80. That's going to be our x-intercept. And our y-intercept is where it crosses the y-axis. That's at 0, -30. That shouldn't take you very long. Again, it's really simple, something you guys should be familiar with. Now, the x-intercept and the zeros are very closely related. Remember, x-intercept, zeros, fluids, and solutions are all interchangeable. The only thing that's different for this line is that you're going to write the 1.8 with x equals instead of as a point. The x-intercept should always be a point, but anytime asked for zero solutions or roots, you would write that with x equals and then the actual x value. Alright, last thing we're going to talk about would be our end behavior. So that's going to be where this arrow is going and where this arrow is going. So remember, when x points to infinity, right here, that means right side. So let's take a look at the right side of our graph right here. So if they want us to look at the right side first, we got to figure out, is my graph going up or is it going down? Well, clearly we can see it's going up, right? But the notation you use for going up would be f of x, arrow, positive infinity. Next, they want us to look at x approaching negative infinity, which is the left side of the graph, which is right here. Now, this is interesting because our graph is neither going up nor down. So when you guys see something like this, and this is not something you guys should be too focused on at this point. We're going to talk about this more in detail. I think in third quarter, near the end of the second quarter. You would actually use a number instead of positive infinity or negative infinity to represent up versus down. If you're just going like flat, or you're approaching a flat line, you would just tell me what that number is that you're approaching. So this graph is approaching 1. 1 is that kind of the highest value it can go. It's not going to go above that because it's staying flat. So if you see something like that, instead of up or down, you would just say, what's the number? Where it's kind of leveling off that, which in this case would be 1. Okay, so all that information, that's just for one graph. You guys are going to see that a bunch of times. Each time we get to a new unit with a new type of graph, we're going to revisit this information. So make sure you guys know how to apply this to really any kind of graph that you might see. Okay, we're going to wrap up with this one right here. Now, this one has an asymptote. I told you guys we weren't going to focus too much about that or on asymptotes until we get a little later in the year, but we're just going to revisit that now and see how it applies with these concepts. So for the domain, again, you want to think, where does it start, where does it stop? What's the furthest to the left I can go, what's the furthest to the right I can go? So you'll notice that this red dashed line, it's like a wall. A vertical asymptote, which we'll talk about more later, is like a wall that you're graphing across. It'll come up next to it like this. It'll come towards it and kind of straighten out. It'll go alongside the asymptote, but it will never cross it. So the furthest to the left that I can go is whatever the value of the asymptote is, because the asymptote cuts off your graph. You can't go past it. So that's at -2. So my domain, the furthest to the left I can go is -2. And then you'll notice that it goes off the graph forever to the other side towards positive infinity. I'm not going to include a bracket here. I'm going to use a parentheses because I'm not actually including -2. I can't cross or touch -2. That's where the asymptote is. I just say that that's the leftmost barrier over the wall. That's why it's a parentheses, not a bracket. And then for my range, you can see that my graph's going down forever and up forever. So if there's no stopping your graph, just free flowing in both directions, up and down forever without any breaks, that would be all real numbers, or negative infinity to positive infinity. Now again, when we're looking for a maximum or a minimum, you guys will be looking for ditches and hilltops. We do not have either of those. So this graph would not have a local maximum or minimum. So just write none. Alright, the increasing interval. So if you guys look at the graph, if I trace the entire graph, green, if I trace the entire graph is rising. There's no point, if you guys are tracing the graph from left to right, there's no point on the graph where you would go down. We always trace or draw or write our graphs from left to right. So as we trace it from left to right, we're just always going up. There's no going down. So we're going to have no interval of decreasing. We're only going to have an interval of increasing. And that's going to be along the entire x-axis that contains our graph. So again, it's going to be from -2 to positive infinity. If our domain is -2 to positive infinity and our graph, the entire graph is rising, then our interval of increase should be the same as the domain, because it's increasing on the entire domain. And then obviously we don't have any flat sections, so we wouldn't have a constant interval, so you just write none for both of those. Alright, let's take a look at the x-intercept. So it's another decimal here. Let's call that -1.5, maybe. Close enough. Approximately -1.5 is where x-intercept is. So the y-intercept is at 0, 2. And again, for zeros, you would write x equals, and then whatever the x-intercept was, but not as a point, just give me the x value. And then lastly, we have our end behavior. So I'm going to circle our ends of our graph. I'm going to add the arrows there. Circle. So again, as x is approaching positive infinity, that's how they represent the right side of the graph. My graph is rising ever so slightly. It's not going straight up, but as long as it's going, it has an upward tendency, that's considered going up. So use positive infinity. And then this is actually incorrect, and we'll talk about this more in detail when we get to this unit where we talk about this type of graph. This should actually say -2 to represent the left side of my graph, because you can't actually get to negative infinity. Negative infinity is over here, because that invisible wall where the asymptote is there, you can't get there. So when we're trying to say left, we want to say the leftmost value we can get to, which is usually negative infinity if there's something blocking us. But because we have that asymptote blocking us, the furthest to the left that we can go is -2. So we use that to represent left instead. So as my graph, now this one you do have to be careful. Imagine that you're going towards -2. If we're going towards -2, we have to trace our graph backwards. We would almost never go from right to left for anything else. When we're talking about end behavior, we're going towards -2. We're going towards the left. We're thinking about going towards the left of the graph. That part of my graph is going down. So on the left side of my graph, I'm going down, and on the right side, I'm going up. So you would use negative infinity on the left and positive infinity